Okay. Now, just to remind you, last session we've been talking about different rules used to solve second order differential equation non-homogeneous one. And as you remember, at the end, our solution y equal y complementary part or homogeneous part plus y particular. Now, let me solve this problem and try to explain what is the meaning of modification rule. Have a look. I took here the non-homogeneous, which is 3 d square y over dx square minus 6 dy over dx equals 0. You can see here, the homogeneous. Then I wrote here the auxiliary equation or the complementary equation, which is 3, as you can see. This is m square minus 6. This is m equals 0. Then I solve it. I solve it. As example, I took here m as a common. What is left? 3m minus 6 equals 0. So either m equals 0 or this part equals 0. I solved this part. I got m equal 2. Now 0 and 2 are real but different. So what I will write? I will write that the complementary will be a exponential 0 is 1, so a, plus b exponential 2x. Now this is the first half part of the equation of the question. I solve it. Now before I go to the particular, what I will see, I need to compare the right hand side part of the equation, of the original equation, with the solution here in the complementary. If there is similarity, I need to do modification. What similarity is this here? Have a look. Now, what I have here, constant. The function is constant. And here in the complementary, the function here is also constant, which is a. And to avoid having confused between, or let me say, overlapping between the complementary part and particular part, I cannot assume y, which is in the table, y equals c directly. We cannot do this because here will be constant and here be constant and they will have overlap. Okay, so what I will do, I will multiply c by x. Right? I will multiply. This is the modification. You see here, I multiply. It's supposed to be from the table only c, because here I have only constant, so only c. This is from the table. But what I do, I added here, multiply here by x, because you can see here in the complementary there is also constant. So in the homogeneous, non-homogeneous constant and in the complementary constant, then I need to do modification. Next, we go through the same procedure. We find y dash, as you can see here, which is c now, y double dash, which is 0. Substitute here and here. We approaching this value. Then we solve for c. We got c minus 3. So I will write y equal minus 3x. Done. This part is the second part I need to add. So the modification happened because there is similarity between the right-hand side function and the new solution for the complementary part. In this way, we need to multiply by x. Now let me take another problem on modification rule. I'm given this equation. Have a look here. This is second order differential equation. I will solve the complementary part, the homogeneous. As you can see here, this is 3m squared plus 10m minus 8, sorry, 8 only, equals 0. Okay, here we are, sorry. Here we are. Now I solve it by factorization, by quadratic formula, it doesn't matter. You solve in any one of them to get the solution. I got the solution here, as you can see here, 2 over 3 and minus 4. I will write the complementary solution. Have a look. A exponential 2 over 3x and b exponential minus 4x. Now here until this point I completed the complementary part. Done. Now before I go for particular, I check here. Here what I have exponential minus 4x. But here also I have exponential minus 4x. Oh, there is similarity, I need modification. Okay. If I go to the table, I know that I will find that y equals c exponential minus 4x. This is the solution, the particular. Okay? But because the similarity between complementary and the right-hand side function, I need to multiply by x, as you can see. Okay? Now when I multiply by x, this is the new p. I go to find y dash and y double dash to substitute. Here, as you can see, I have two functions. It means u v, right? So to differentiate will be u v dash plus v u dash. So I differentiate it, I approach here. Differentiate again, I approach here. Okay. I leave this stuff to you because you know how to differentiate. Now next I will substitute in the original function, the original equation, and solve for the constancy. I got the constancy. Then we need to back substitute here. This is the new particular, let me say, solution. I added to the complementary solution, and here we are. This is the final answer. Now I'm explaining the methods here, but at the end we will solve one problem together. Have a look. The last rule, we completed the basic rule, we completed modification rule. Let's go for the sum rule. Sum rule, when we have function on the right-hand side function contain more than one function. As example, here sine function, here exponential function. Now let me solve it. For complementary, I have here m square plus 4, as you can see here. I solve it, take 4 to the other side will be minus 4, take square root here and here. Okay, we have complex. Alpha is not there, 0. So the solution will be sine 2x, cosine 2x, by constant definitely. Okay. Now before I go further, okay, what I understand here, have a look. Yp from the table, for sine, it will be a sine 2x plus b cosine 2x. But I have another function which is exponential, so I will write plus c exponential x. This is supposed to be the solution. Taken from where? It was taken from the table. Okay, but just a minute. Here I have sine 2x, and in the solution here sine 2x, there will be overlapping. I need modification. Oh, so I need to multiply here by x and here by x. You see? Now in this example, we describe this example to explain the sum rule. But it seems to be at the same time we need modification rule. We need it because there is some similarity between right-hand side function and the complementary function. So this is my function here. Definitely this one, when we differentiate, it is uv. Also the same thing here because x and 2 cosine 2x. uv here is directly c exponential x. So it's fine. We did the first derivative, then the second derivative, and then we will back to substitute here. We substituted and simplified. Now what I will do, equating parameters for the same variable on either side of the equation. Have a look. 5c exponential and here exponential. So this 5 on the left hand side, 5c, supposed to be equal to 1 here. So I got c. Right? This sine equals this sine. This cosine equals 0 because there is no. So that we can't find these constants. You got it? I mean, as I have a look here, 4a, is there any cosine here on the right hand side? No cosine, that means multiply by 0. So 0 equals 4a, so a is supposed to be 0. minus 4b supposed to equal 1 here. So I found b, which is minus 1 over 4. When I got them, I back to substitute here for a and b and c. In this way, I got the particular solution. I added to the complementary, which represent the final answer for the problem. This is the complementary, and this is the particular solution. Now, my advice when you solve these type of problems, work in steps, don't jump. And make sure to not to miss any signs, any number, any symbol. All of them should be there clear. Otherwise, if you lose anything, it will be accumulated and the answer will be wrong at the end. This is our table. As I mentioned, yeah, we will select it from the table, but if we need modification, we have to go for modification. It doesn't matter if we have more than function, we can add them because some rule allow me to go for more than function. Another example. I'm given here second order non-homogeneous differential equation. He wants me to find yp, but he told me that the complementary, after we solve it, it's found in this way. Okay, I will see. Let me see here, exponential 2x, and in the complementary there is exponential 2x. Modification is necessary here. So I will say the particular will be c by x exponential 2x. Now I found the first derivative and the second derivative. Let's substitute here and here. We substituted and we simplify, as you can see here. By the way, I advise you, when I complete, try to revise these problems. Check them, paper and pen, and try to solve them by yourself and check your answer with what is going here in the example. I mean, I leave these details to you to experiment them. So we solve it. You can see here exponential here, exponential here, exponential here, exponential here, and exponential. We can cancel them. At the end, one equation with one unknown, which is c, we got c. Very easy. We got c, we back to substitute for c here. This is the complement particular solution. Now, what I want you to do, I want you to solve this problem first, which is y double dash plus 2y dash minus 3y equal 8 exponential x. Okay? And tell me which rule you are gonna use. Is it basic or modification or sum? Definitely there is no sum because it's one function. So can you start with it? Tell me what is the complementary first. Okay, I will give you a couple of minutes and then tell me what is the solution for the complementary. Yeah, you can start. Anybody find the complementary solution? Did you found it? Just the roots. What are the roots?
N is equal to 1 and minus 3.
Excellent, thank you. So 1 and minus 3, exponential 1x plus exponential minus 3. Let me put here a, b, this is y, complementary. Okay, just a minute. Oh, I have exponential x and exponential x. So you tell me what method we are going to adopt here. Basic or modification rule? What do you think?
Modification.
Excellent modification. So we will say that y p equal, let me say c, x exponential x. And when I solve it, it will be y p equal, let me say c exponential x when I differentiate x minus, or plus, sorry, plus cx exponential x. Differentiate again to find yp double dash, yp double dash, this dash. Then I will find also cx, it will be c exponential x, this is derivative, plus c here, similar to c exponential x, so I can say c exponential x plus cx exponential x. Okay, so it will give, let me write it here, 2c exponential x plus c exponential cx exponential x. Now I come back to substitute here and here and here. You have all of them. Can you substitute and cancel exponential x to find c? Tell me what c will look like. Okay, do it please. Have a couple of minutes to find c. Anybody found c? Okay, let me solve it. Let me, seem to be now what is it? Okay, y double dash, it means c 2c, sorry, exponential x plus c x, okay, plus 2 multiplied by the y dash. What is y dash? C exponential x plus cx exponential x, close brackets, minus 3, where is my yp? Cx exponential x equal, what is to the right hand side? 8 exponential x. Okay, now I will come here. This is 2c exponential x, and 2 multiply here and here. No need for this now anymore. Okay, and this is 2c exponential x. Okay, that's it. So I will say 2c exponential x plus 2c exponential x. This is 4c exponential x. So I will write 4c exponential x equal 8 exponential x, because these are exponential x and these are exponential x. Cancel these. What is left? 4c equal 8. So from here I will say c equal 8 over 4, which is equal to. So I come back to the original assumption here to say that y particular equal c, which is 2, x exponential x. This is the particular solution. Now, if it is clear, can you solve the last one here, just this one? Just tell me first, what is the complementary solution? What are the roots? Okay.
4 and minus 1.
Great, just a minute. 4 and sorry, you can write the complement in this way. Y complementary equal A exponential 4 plus sorry B exponential minus 1 minus X. Okay. Now before I go further, have a look at this exponential minus X and this exponential minus X. You see they are similar, so need modification here. So if I come to write the particular, have a look how I will write the particular. YP. For this one, 3 exponential 2x, it's fine. There is no confuse here. There is no overlapping. So I will write here C exponential 2x. This is the first function. For this function, I will write plus dx exponential minus x. You got it? Modification occurred only for the second function, which is exponential minus x, because there is some similarity with complementary function. Now I go to find, you see the remaining is a procedure. Find yp dash, yp double dash, substitute here and here and here, and solve for the constant C and D. Now if you go through this, I expect that you will have two equations. Okay, you may have two equations if you solve them, or you can equate the items on either side of the equation to find the constant C and D. I will stop here. If you have a question regarding second order